This is Unit 9, Lesson 6, Video 1. We're going to do more equations with radicals, but this time we're going to apply it to Pythagorean theorem. Okay, so the Pythagorean theorem says for any right triangle, so it has to be a right triangle, a squared plus b squared equals c squared. So these are their side lengths. So to know it's a right triangle, you should have this box here to show that there's a right angle. Okay. So A and B, the parts of this right triangle. A and B are the legs, and C is what we call the hypotenuse. So A and B can be interchanged. It doesn't matter which one's A, which one's B. But the hypotenuse, it matters. C always has to be the one across from the right angle. That's the hypotenuse. That's the one that should go on the side by itself. Okay, so let's solve equations. Use the Pythagorean theorem to find the missing side length. So I'm looking for this. So this 13 is the hypotenuse, and so this x is a leg. So I can call that A, 12 can be B, 13 can be C. It has to be C. So I'm setting up this equation. So A squared, so x squared plus B squared, so 12 squared equals 13 squared. So I square 12 and I square 13. Let's subtract 144 from both sides. And then we will take the square root now. Usually when you draw in your radical, you have to write plus or minus. But since this is a side length of a triangle, we can't have a negative number. So I only need to worry x equals 5. Okay. All right, let's look at the next one. So we can see what we have here. So we have 8 is a leg, we'll call that A. 12 is also a leg, we'll call that B. And now our hypotenuse is x. What we're trying to find is C. So 8 squared plus 12 squared equals C squared. So 64 plus 144 equals C squared. And so then 64 plus 144 equals 208. And then we square root. And if you take the square root of 208, you get a decimal. So we want to make sure that we reduce the radical. We don't want decimals, we want exact answers. So I need the largest perfect square that goes into 208. And then into 16. So 16 times 13. So that's 4 square root of 3. It's actually x equals 4 square root of 3. Okay, so if it's not a perfect square, then you simplify your radical. Keep it in radical form. Okay. Now we're saying you're going to use Pythagorean theorem to see if the triangle is a right triangle. So if it is a right triangle, then this will be true. A squared plus B squared will equal C squared. So I set this up and see if I get a true statement. So 22 is my C. So I have 21 squared plus 7 squared. And I want to know, does that equal 22 squared? Okay, well, I just type in 21 squared plus 7 squared, and I get 490. Does that equal 22 squared? That is 484. Those are close, but no, not equal. So this is not a right triangle. And that's because a squared plus b squared does not equal c squared. Okay, let's check this one. So this time my c is 7 square root of 2. So my legs, my a and my b, are both 7. I want to know, does that equal 7 times square root of 2? And what's important when there's a radical, so you have to square the whole thing. Okay, so 49 plus 49 is 98. And what you're doing is 7 squared and square root of 2 squared. If you type that whole thing in your calculator with parentheses on the outside, it should also give you 98. So yes, those do equal each other. So yes, this is a right triangle. Okay, so this concludes our Unit 9 material. We're ready to do the last assignment, which is Unit 9, Assignment 9.